Welcome to the video lecture series on finite state automata. So we'll be discussing about finite state automata today. So what is meant by finite state automata? A finite state automata is a mathematical model. It's a mathematical model which accepts regular languages. So which accepts regular languages. So whenever you give a regular language, if it is accepted by a mathematical model, we can also say that model as a finite state automata. So what are the types of finite state automata? There are two types. So two types of finite state automata. One is deterministic finite automata. Deterministic finite automata, and in short we call it as DFA. And second one is non-deterministic finite automata. So non-deterministic finite automata. So in short it is called as NFA. So these are the two types. So what is the difference between deterministic and non-deterministic finite automata? For example, deterministic finite automata for a specific state, and for a specific input, specific state and for a specific input, if there is at most only one move, if at most one move, then it is DFA. Then we call it as DFA. Now what is meant by at most one move? For example, I have a state called as state X. Let us assume that I have a state called as X, and I have another state called as Y, and I try to apply an input called as A over here. So in state X, if I apply A, it goes to the state called as Y, and in state X, if I apply B, it goes to state X itself. So for a specific state X, if you are applying a specific input A, you are going to state called as Y. So there is at most only one move for a specific input in a specific state. But when you apply B over here in a specific state called as X, you are going to X itself. This is also called as a transition. Either you are going to other state or going inside the state itself. This is also called as transition. So this kind of diagram is called as DFA. And what is meant by NFA? NFA. For a specific state and for a specific input, for a specific state and for a specific input, if there is more than one move, then it is called as NFA. So then it is called as NFA. So now we will take another example for this one. Say for example, I have X state called as X, and I have Y, and I apply A over here and A here. So you can see that in a specific state called as X, if you apply A, you make two moves. For one A, it goes from X to Y, and for another A, it goes to X itself. So there is more than one move for a specific input in a specific state. So this is called as NFA. So you can categorize in this way. So We'll now discuss about what is meant by finite automata, the architecture of finite automata. So finite automata have a simple diagram like this. You have a tape drive. So tape drive will be splitted into cells. So this is called as cells. And you have a finite control. So this is called as finite control. And you will get two outputs, either it is accepted or it will get rejected. And this is called as a read head. A read head. A read head is capable of moving from left to right, so it will read one symbol at a time. And this tape drive, there are a set of cells here, so these cells are called as memory cells, and this is called as tape drive first. So tape drive, and this portion is called as cells. It's called as cells. A cell is capable of holding only one symbol at a time. Say for example, I have symbols called as A, and I say B, and then this dollar is actually called as an end of the string. So dollar is actually used as a delimiter to find the end of the string here. And this read head will be reading one symbol at a time. So once it reads a particular symbol called as B, it moves to the right side and reads the next B symbol. Similarly, it travels from left to right. And if the string is valid, then the finite control will be giving this statement called as accepted. And if it is not, if it is invalid, then it will say it is rejected. So all the regular languages, all the strings of regular languages can be incorporated inside this tape drive. So it will accept it or it will reject it based upon the pattern of the language. So this is called as architecture of finite state automata. So to understand this, what is tape drive? A tape drive has the input strings. It is splitted into memory cells. So each cell capable of holding only one symbol at a time. Each symbol is capable of holding only one symbol at a time. So this is called as tape drive. So all the input strings are fed inside this tape drive. And what is meant by read head? Read head reads one symbol at a time. From a tape drive. Reads one symbol at a time from a tape drive. So it moves from left to right direction. It moves from left to right direction. And what is meant by finite control? So finite control accepts or rejects a string. So it accepts or rejects a string based upon the language pattern which is fed inside the finite state machine. And one more important key point to notice: finite state automata cannot store strings. Or state. It cannot store strings or state because it lacks memory. So it lacks memory. So if you want to find whether the string is a palindrome or if you have equal number of A's or B's, such kind of process cannot be done in finite state automata, because you don't have a memory called as stack like memory in finite state automata. So lack of memory actually makes this finite state automata incompetent to solve such kind of problems. So we will define the formal definition of finite automata. Finite automata can be formally defined as a phi tuple model. So I can say that it is called as a phi tuple model. So finite state automata, I can say that F is equal to, so Q, then sigma, then delta, then Q naught, and capital F. So we will discuss what does each and every parameter means. Q is called as set of states. So we can say that set of states varies from Q equal to Q naught, Q1 up to Qn. So we can have any number of states inside a finite state automata. And sigma, what is sigma? Sigma is called as set of input symbols. Set of input symbols is called as sigma here. Say for example, if I want to have two inputs called as 0 and 1, I can write that sigma equal to 0, 1. So this is the way. And similarly, if I have inputs called as A and B, I can write sigma equal to A and B. Now delta. The third one is called delta, is called as a transition function. So transition function. So what is this transition function? So if you try to make a move from one state to other state, or if you are making it move inside the state itself, then that is also called as a transition. So how to write the transition, define the transition mathematically? So there are two types of transitions. It is related to DFA as well as NNFA. So now if it is a DFA transition, I can write like this: transition tends to. So you will be applying the inputs on states. So set of states can be called as Q, capital Q, and set of inputs we can call it as sigma. So set of states into, that is, you are applying this input, it's a sigma. So set of input sigma is applied on set of states over here, and where you go to another state. So all the states are inside Q, so set of states equal to Q. So even if you apply an input from one state in any state, it goes to another state. So that is also inside the part of set of states. So this is called as DFA. That means number of transitions will be at most only one transition over here. And if it as an NFA, you can say that set of states Q, set of input symbol sigma. So you will not have only one state movement over there. You will have more than one movement in NFA. So you can write, instead of Q, you can write 2 to the power of Q. So at most this, it is NFA. So we can say that it is called as 2 to the power of Q. It is called as an NFA over here. And Q0, Q naught is called as initial state. We call it as an initial state. And F is called as set of final states. So set of final states. So in a finite state automata, you can have only one initial state, but you can have more than one final state. So I can say that final state F is a subset of, I can write like this, subset of Q. So NFA and DFA only varies in this transition. So only Only this transition varies for NFA and DFA. Other than that, the formal definition of NFA and DFA are same. So, thanks for watching the video. Have a good day.